Hi, my name is Saketh Koona, and for my CS 2316 final project, I'm going to be looking at crime patterns in LA. To do this analysis, I used a threefold approach. First, I looked at geospatial data and looked for hotspots or certain districts that had more crime than others. Second, I looked at temporal patterns, most notably the times of year and whether the crime would be more likely then or during other times of year. And finally, I looked at the effectiveness of police stations and law enforcement in the district, and I used a distance-based algorithm to calculate the effectiveness of that. Before I did any analysis, I had to collect and pre-process the dataset for further use. So I had three datasets in total. The first one was a downloaded dataset which contained accounts of Los Angeles crimes from 2020 to 2024. The second was time series data of crimes in LA from the period of 2011 to 2019. And finally, I web scraped the locations of various police stations in LA using Selenium. The first dataset I used, which was the downloaded dataset, included details of descriptions of crime incidents in LA from the years 2020 to 2024, and this was found using data.gov, and we downloaded a CSV file which was further cleaned. In that cleaning process, we removed NaN values and dealt with them in other ways, such as filling them with placeholders, as well as dropping columns or rows entirely. Finally, we converted latitude and longitude values to geospatial coordinates. This was done so we could use them with the GeoPandas module from Python. The second dataset was the JSON or API dataset, and this uses the LA City API from the City of Los Angeles. This contains monthly time series values to be calculated from the number of crimes that occurred from 2011 to 2019. Since the dataset had a limit of 1,000 rows per request, as well as 2.5 million total rows, this made it very hard to gather all the data. To do this, we adopted a sampling approach and used resampling and interpolation to fill in the gaps. Here's a more in-depth look at the code. As you can see here, these constants determine the sampling steps and the sample size. So here we have 50,000, which means every 50,000 rows we stop, and a sample size of 10, which means we take 10 samples every 50,000 rows. Here we have the API endpoint, as well as here, where we pass in the offset and other values such as that. And finally, here we'll have the resample and interpolate function, which is used to smooth out the data. The next dataset is the web scrape dataset, and I used Selenium to web scrape the addresses of major police stations in Los Angeles. A challenge I dealt with in this stage was to format the phone numbers from strings to different numbers and integers that I could deal with in the future. And we did that by removing additional characters such as hyphens, parentheses, and alternative numbers / slashes. And finally, we saved the dataset as a CSV file. To scrape the data, what we did was we went through each column row and we gathered relevant information. Now that we're done cleaning and pre-processing, we can finally focus on the analysis. I wanted to answer the question, how is crime distributed along different regions of LA? And to do this, we normalized data and calculated percent splits of crimes in LA based on the region. And we also filtered by various demographics to see if there was any discrepancies. To do this, we would group by the area name and then count up the number of crime occurrences that happened in that certain district. And when we wanted to focus on demographics, we had to create new columns that represented different categories of age. Since the age was a number, we took it and used our define age range function to put it into a different bucket. And based on that, we normalized our percentages and finally returned a combined data frame. The code snippet here shows how we merged all those different columns together using pandas concat function. With an axis of 1 and the different columns that we found from before, we sorted them based on the total, and we can see the different percents. The results showed that, on average, the two most dangerous districts in terms of crime rates were the Central District and the Southwest District. This trend remained consistent for most demographics apart from a few key outliers, and this was crimes against women, against senior citizens, and against children. This can be explained by various factors. One that I hypothesized was the different types of crimes that may occur. For example, total crimes include all subset of crimes that may occur, but crimes against children may not be of the same nature as the crimes against men, and so on, and this may contribute to the different districts. Below is a heat map of different crime occurrences in the area. And as you can see, while a large portion of the data is homogeneous, you see a bunch of orange with little yellows in between, there are a few visible hotspots. One of them is right here, which is the central 77th Street region. One is down here in Pacific, as well as some along here. Now, based on these few hotspots, we can gather they match with the results on the table we generated before. Furthermore, you can also click on this link to interact with this map, zoom in, and see how concentrated these values are. Moving on. The second question that I wanted to answer was how crime patterns in LA changed throughout time, most notably how they changed with the seasons. To do this, we had to do several things. The first was to add a column to measure the various months of the year. We had the date times, but we didn't have any column for the months. So we used a function to map each value of a month to different seasons, such as winter, spring, summer, fall, etc. And then we summed the number of crimes that occurred in a given month using the group by function and aggregated the results. Finally, we plotted those results out in a bar graph to help us better contextualize these values. The results show that while crimes remain relatively consistent throughout the fall and spring, there's a massive uptick in crimes during the summer and a significant decrease in those in the winter. And I attribute these to a number of factors, but the hypothesis that made the most sense to me was the huge influx of tourists in the summer. This can cause an increase in petty crimes such as pickpockets and burglaries. Moving on to Insight 3. Next, I want to look at which police stations were more effective in stopping crime at their regions. And to do this, we used the GeoPy module to calculate coordinates of police stations, as well as a distance algorithm that calculates how far away a crime is to a respective police station. The first step is to locate these police stations by calculating their latitude and longitude values. And we input the addresses that we gathered in the data cleaning process, and we spit that into the GeoPy nominatum API, and we get out the coordinates. We use a rate limit of 5 seconds to make sure that we don't overwhelm the API. The next step is to actually calculate these distances. To do this, we use GeoPy's geodesic function, which takes in different coordinate values and outputs the distance in miles between those two coordinates. And the final step is to assign each crime to a police station and calculate that distance. And based on those distances, we again group by the area name, and we find the average distance from a crime to a police station. And for further analysis, we say that lower average distances correspond to lower effectiveness. The results actually disproved my hypothesis that police stations in central and downtown areas were less effective. The results show that across the board, crimes occur farther from police stations in downtown districts rather than in suburbs. This shows that police stations in the central downtown areas are more effective at keeping crime in control. Moving on to the next insight. The next question that I wanted to answer was, how does the violence of a crime affect its resolution, whether an arrest was made, whether the investigation was ongoing, and so on. So to do this, we assign crimes violent or non-violent based on different keywords, and then we group by those statuses and determine the probability. The first step is to create a violent or non-violent function that categorizes crimes into two categories: violent or non-violent, based on different keywords in their descriptions such as gun, weapon, rifle, knife, etc. Then after we create that column, we group by that column as well as the resolution description, and we unstack to destroy the multi-level index that Pandas has generated. Finally, we normalize those values to create percents which we can analyze. The results show that crimes were actually more likely to be resolved if they were more violent. And another interesting thing that the results show is that violent and non-violent crimes have a massive percentage of crimes which are still not resolved. And note that this is relatively new data, 2020 to 2024, so this may be slightly biased. Our final insight and visualization. Finally, I want to answer the question if there's a correlation between the place of a crime and the severity of it. First, we created a function that determines whether a crime happened in a public or private location. This is very similar to the violent or non-violent function that we used in Insight 4, except the keywords are changed. After applying both the public or private and the violent or non-violent functions that we have defined earlier, we create two new columns called location type and severity to measure those in categorical values. Now, this doesn't work with correlation, so we have to convert those into numerical values. And to do this, we used a one-hot encoding technique in Pandas to do that. Finally, we calculated the correlation matrix using the .core function. Surprisingly, there was very little correlation between the type of location and the severity of the crime. But again, further analysis is needed to determine more effective ways to measure these factors, because once again, we based our approach on keywords, and this may not be as accurate as we want it to be. Furthermore, the data can be explained by the fact that a lot of domestic abuse cases, which can sometimes turn violent, happen in private places. This heat map further corroborates the data, and it shows that the correlation values are very low at 0.07, which means that there's very little relationship between these two variables. Some takeaways from this project. So, overall, crime in LA seems to be concentrated in several areas more than others. However, this isn't an extreme concentration as crime rates remain generally homogeneous with upticks in percentages in several key areas such as downtown, Central, Southwest, and 77th Street. There are also seasonal patterns which affect the rate of crime incidents, and this could be used to perhaps increase law enforcement during those seasons. Some challenges that I dealt with were parsing the JSON/API dataset, dealing with more rate limit issues with the API of GeoPy, as well as finding visual patterns within locations.